Creating a game for the Atari 2600 in the late 1970s and early 1980s was nothing like modern game development. There were no engines, no debuggers, no operating system, and no safety net. Developers were forced to think like hardware engineers, working directly with the machine at the lowest possible level. This article walks through the complete process of creating an Atari game, from the first idea all the way to a finished cartridge sitting on a store shelf. Step 1. Designing an idea that the hardware could actually run. Before any creative ideas could take shape, developers had to ask a brutal question. Can this game exist with 2 sprites, 128 bytes of RAM, and no video memory? Because of these limits, early game concepts were intentionally simple. Single-screen gameplay, very few moving objects, minimal animations, little or no text. Games were designed around what the hardware could do, not what the designer imagined. Step 2. Planning everything on paper. Before writing code, developers planned the entire game on paper. This included exact sprite positions for each scan line, CPU cycle timing, memory allocation, when logic could safely run during vertical blanking. This step resembled circuit design more than software development. Step 3. Dividing the 128 bytes of RAM. Memory management was critical. With only 128 bytes of RAM available, every variable had to be carefully planned. $80, player X position $81, player Y position $82, enemy X position $83, enemy Y position $84, score $85, timer. There were no abstractions, just raw memory addresses. Step 4. Writing the game in 6502 assembly. All Atari games were written directly in 6502 assembly language. There were no high-level languages or engines. Start. LDA number 0 STA GRP 0. Clear player sprite STA column. Set background color. The code was divided into 3 main sections: VBlank logic, game calculations, kernel, real-time screen drawing, overscan, cleanup, and preparation. The kernel had to be cycle perfect. A single missed clock cycle could break the display. Step 5. Drawing the screen in real time. The Atari had no frame buffer. Instead, the CPU had to feed the graphics chip while the television was actively drawing the image. This technique was known as racing the beam. For each scan line, the CPU had to position sprites, set colors, trigger drawing at the exact right moment. Many visual effects were actually timing tricks rather than true graphics features. Step 6. Testing on real hardware. Early developers did not have reliable emulators. Testing was done on actual Atari consoles connected to real televisions. Common issues included screen flicker, color distortion, loss of synchronization. Some bugs appeared only on certain TV models. Step 7. Aggressive optimization. When the ROM was almost full, developers entered a phase of intense optimization, removing redundant instructions, merging logic paths, using self-modifying code, reusing memory locations. Saving a single byte could mean adding a new feature. Step 8. Overcoming ROM size limits. If a game grew beyond 4 kilobytes, developers implemented bank switching. Writing to a specific memory address would trigger hardware inside the cartridge, swap a different ROM bank into the CPU's address space. Software directly controlled physical hardware behavior. Step 9. Creating the master ROM. Once the game was finished, the final binary was produced, a master ROM image was created, EPROM chips were programmed. Each chip contained the complete game. Step 10. Manufacturing the cartridge. The ROM chips were soldered onto small circuit boards. These boards were then placed inside plastic cartridge shells with edge connectors. Each cartridge became a physical extension of the console. Step 11. Quality control. Every cartridge was tested to ensure the game booted correctly, no graphical glitches appeared, the hardware connection was reliable. There were no patches or updates. What shipped was permanent. Step 12. Packaging and distribution. Finally, the cartridges were packaged with printed manuals and box art. The game was shipped to retailers and entered the market. Conclusion. Developing an Atari game was not just software development, it was precision engineering. Every frame, every byte, and every clock cycle mattered. The finished cartridge represented months of hardware-aware craftsmanship, forever frozen in silicon. Strong CTA, ready to explore more tech history? Visit smartchoicelinks.com right now.